Here we go with a few examples of energy. Here I've got a wind-up toy. So I have to do work to turn this dial on the little mouse. And oops, you can hear that it wants to go. When I turn the dial, what I'm actually doing is compressing a spring, loading a spring. So right now there is elastic potential energy in the mouse. Then I'll let it walk. Oops, there we go. There it goes. And eventually it will run out of juice. Maybe not before it hits the, oh, there it goes. So now all of its energy has been dissipated. It went to sound and heat. Here's another one. This one has a really obvious crank. So you can see on this one, you can see the spring as well. So I'm cranking it up, I'm winding the spring. And then when I let it go, ooh, yikes. There we go. The spring unwinds and it slowly dissipates its energy. Here is a device, maybe you've seen these hand crank flashlights. I do work, I exert a force over a distance, and that work ultimately is dissipated as light and sound. Here's a ping pong ball, I'll drop it. Right now it's got gravitational potential energy. Okay, it never bounces up to where my hand originally was. I always wish it would. But what happens is when it hits the ground, or the table, the ping pong ball flexes a little and stores energy in the flexing of the ball. It's very difficult to see, but we'll have to Google some slow motion videos so that you can see that deformation. Okay, one more, one of my favorites. This is a Matchbox car toy, and with this toy you can take a car and push it into the Matchbox car toy. And when I pushed that, I exerted a force over a distance. I loaded a spring, so there's elastic potential energy there. When I release the spring, it'll give the car kinetic energy. All right, I hope those examples helped it make sense.